Hello my dear viewer, my name is Klancher and I am a self-taught programmer. In this video I will debug a programming exercise called Snail Sort. Now you might be wondering, what is this website that we are on? We are currently on codewars.com, which is a website with many useful things. One of them are coding katas. Now coding katas come from the term kata in karate, which is an exercise we do to improve our skills. Now this user interface looks like this. This is a window with instructions for the kata. These are tests to test your kata against. And this is the code that you write. As you can see, I have already written some code right here. Now, to quickly demonstrate you how this works is that first you read the instructions, you write this code, and then you press this button to test this code with these tests. Now currently there are only two tests here. 1, 2. And if we test against them, yes, that is the term, to test a code against tests. And we do that. We see that both tests are green, which in other words mean that they pass. Alright, but that isn't enough to finish this coding kata, because the website has the system that first you see some sample tests, but you don't see all of the tests. If you want to test against all tests, you click on attempt. Now, as you can see, we have some red color over here, and I think you can figure out that red means failed test. And we can read over here that this code has passed 81 tests and failed 42 tests. Now, if we do this again and again, we can press attempt again. And it's the same, it's still the same number. If you press the attempt again, it's different number. Now we've got 78 tests passing and 18 failing tests. Why is that? It is because every time we click attempt button, we run it against some fixed tests and some random tests. And those random tests are of course generated randomly, which means that sometimes they are different in every run. So our code passes differently to different amount of tests each time. Now, this is the introduction to the coding kata. Now, let's go check out the instructions so you can see what is this kata about. Now, first is this called a snail sort. And it's called a snail sort because we will be sorting numbers or integers, as we call them in programming. Integers, this is an integer, this is an integer, 0 is an integer, 8 is an integer, 128 is an integer. We will generate a list of integers in this kind of fashion, in a snail-like fashion. Now, you might be wondering, what is a list in Python? What does this mean? I will explain it to you right now. First, if I go in the Python, what is the name of this? It's called Python program. I forgot currently. But right now I can write Python code. This is a kind of a Python compiler, or let's check it out. How is it called? It is called well, Python it's not a script. It's Python command prompt, maybe. Alright, that is my homework to figure out what is this even called. Alright, I'll make my mark on my notebook. Now let's open Python. Alright, it is down here as you can see. First, integer is 1, integer is 5, integer is 8. We can allocate variables to an integers. For example, integer number 1 equals 1, and if we type integer number 1, we get returned 1. Now, we also have a specific data type which is a little bit complex, more complex than an integer, and that data type is called a list. And list looks like this. We've got brackets, or I will check out the name of brace in programming. It's called a bracket. Alright. A list is enclosed with brackets and has different values. For example, 1, 2, 3, 4, 5, 6. This is a list. We can allocate a list to a variable name, or more correctly, we can allocate a list to a variable name. Yeah, that was correct, sorry. Now, our list looks like this: 1, 3, 5, 6, 3, 2, 1, 4, 1, 1, 4. Alright. And we can print out our list. Here we go. Now that is a list. That is the basics for understanding this kata. Now, we have elements inside our lists. For example, this list has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. Each of these integers is an element. And elements can be anything. Elements now. I will demonstrate in another list. Another list. Look. We can have a string. How are you? As an element. We can have an integer. We can have some more integers. We have bunch of threes and as elements. Or we can have another string. Hey yo. Or we can have a total nonsense of a string. Or we can even have a variable name. For example, our list. And we have created another list. Another list. Here we go. And as you can see, we have put strings, integers, and even variable names into our list. And the output is exactly the same, except that this element, which we put in as a variable name, is now a whole. We get the contents of this variable, because our list was defined here, and our list is another list. So, now you might think to yourself, hey, now we have a list and a list inside of this list. And that is also one of the basic points of our kata. Nested lists. We call this a nested list. Nested like nest, like bird's nest. Now, let's make one nested list again. First, I will just quit this Python console. I think it's called a console. And I will just clear all of the screen and then enter the Python again. And we will make a nested list again. Nested list. And it looks like this. This is an empty list. See? No elements inside. And then we will put in another list. Now, what is this? This is a list with one element, which is also a list, which is empty. Now, we can redefine a nested list to look like this. What is nested list now? It is a list with two elements, each of which is also a list, and the second element is a list and has one element which is 1. Now you understand the basic concepts needed to solve or to follow the debugging of this kata. And why do I say debugging? Because I have already written some code which works mostly as you saw. Look, this is green, but all the tests are not green, so we're gonna debug it. And now with the nested list you know everything. Because if you look at this now, it is a little bit more clear to you what's going on. And if you look at this, you might be a little confused because there are like 1, 2, 3 lines of code. But actually, if we copy this and paste it over here, we still get multiple lines. But if we call it out, you know, it is just on the same line. This is just a fancy multi-line piece of code. As you can see, this variable called array is a list with 3 elements. This is one element separated by comma, another element separated by comma, and the last element. And each of these elements has also 3 elements which are integers. And now, as you can see, snail sort, given an n times n array, return the array elements, arranged from outermost element to the middle element, traveling clockwise. Now, you may be caught up with the array name. Array is just another name for a list. So, this is an array. But it's a specific to a Python language that we don't call it array. We call it a list. But it's good to know that it's called array in Java or C or maybe even JavaScript. Now, return the array elements arranged from outermost elements to the middle element traveling clockwise. Now return elements. Returning something in programming usually means like this. You have a function. For example, this is a function, and function returns you some data. Now, usually you put in some data and you output some data from a function, and this kata expects that you will get an input of n times n lists, and then you have to return elements arranged from outermost element to the middle element traveling clockwise, which looks like this. Which looks like this, clockwise, see? And that's why this kata is named snail sort, because this shape looks like a snail. Alright. And n times n array, if you don't yet know what it means, it's simple. Because, for example, n times n array means that we have an array with 3 elements, and each of these elements has also 3 elements inside of them, and that is 3 times 3 array. And this is visualization of 3 times 3 array for the purposes of this kata. This is a visualization of 4 times 4 array for the purpose of this kata. Now, let's see what does this code mean. I will open it like this so it's more visible, and I will enlarge it. Now first, as we can see, this is a function called snail, and it gets one variable which we call input data, which, as we know, is a n times n array. And first we define an empty list and we call it output list. Here we will be appending correct pieces of data, and we will curate a correct answer under this variable name output list, and at the end we will return this variable out from the function, and this will be the correct answer. Now the second thing is that we have here try and except statement. Try and accept statement in Python means that we try to write this piece of code, and if that fails or returns any error, the except code block will run. So for example, I will show you how an error looks like. First, I will create a sample list, which is 1, 3, 7. I didn't say that yet, but if you want to access specific element from a list, you can type in its index number. And index numbers in programming are 0, 1, 2. So if I want to access the 3, I say sample list, and I put brackets like this, and I type in the index number of an element that I want to get. And the 3 has an index number of 1, because the first element in programming is always 0, second is 1. So I say 1, and the program will output 3. Here we go. Now I will make an error. For example, if I want to get the 5th element, the element with the index of 5, but this list has only 3 elements inside. So what will happen? We will get an error. Look, index error, list index out of range, and also program stopped. Now, but if you would have when we have a try and accept statement, the program doesn't stop. It just says, okay, and it goes on to the accept part of the code. Alright. So, as you can see, in the try statement we have a while loop. That means that I have made such piece of code that will just go around and around and around while true, that is around, true, around, and when there is no more elements, we will have an index error. And index error will cause the program to run except part of block, which will just return everything that we have appended to the output list. So, what does this part inside of the while loop look like? As you can see, I have divided into 4 parts. Why did I divide it into 4 parts? It is simple, because I have divided code to work in a specific way. This is a visual representation which I will use to explain the working of my code. This is a nested array of 1, 2, 3, 4 times 1, 2, 3, 4 elements. And this is output. I will write output here. Now, I will pick crayon color and take red, and as you can see, we will travel in this direction. First here, then here, then here, and like this. That's the task of the code. Now, 4 blocks is because I have written a code that firstly deals with this part of the input, then with this part, then with this part, then with this part, and then it just does it again, first with this part and then with this part. So first, 4 element in input data. If, for example, if this is an input data, each element is an array inside. If this is an input data, each element looks like this. This is an element 1, 2, 3, 4. Alright. And for each element in input data 0. Now, input data, we take the first element out of it. So we take just this element. And this element also has sub-elements. So for element in elements of here, we have this one, this one, this one, and this one. We have 4 elements in the first element of the input data. You see how it goes with the nested lists. And so we just take the output list and append each element. So we have the output list here, and we just append each element. So I'll take the pencil, turn this to black. We loop through all of the elements of this list, and it looks like this: 7, 4, 8, and 2. Alright. And then we've done this. What does happen now? This part of code happens. Input data dot pop, 0th index of element. Pop function removes a specified element from the list. This is list, this is pop function, this is the element, this is the index of an element we want to remove. Now, it looks like this, visualized. We just cross over this first element. This is no longer here, because we have popped it off. Alright. Now, second part of code takes every list in input data, and if list isn't the last element of input data, we get the last element of this specific list, and we append it to our output list, and then we remove this set element. What does that look in action? Well, it looks like this. We take each list, this one, this one, this one remains, but we don't take. Now we iterate over each one of those. This one, and this one. But this if statement prevents us to do any action with this, which is the last list of this list. So we just take this code, and this part of code, which is -1, means that we take the last element. So we take 6, and in another list, the last element, we take 2. And what has happened then? We just remove each one. Well, more appropriately, it looks like this. First we take the 6, and then we remove it. Then we take 2, and then we remove it. And we do it for as long as we don't get to the last element. But because this is already last element, the program stops here. And this is the end of the second block of code. We go forward to the third block of code, which is reverse the last list and append it. Or in other words, just take the last element of the input data. What is the last element? Now we have this is one element, this is one element, and this is one element. Last element of input data is this, the last list. And we are traveling in this direction. And if we would just append this list, we would append it like this: first 7, then 9, then 1, then 8. But that wouldn't be correct, because it wouldn't be in this direction. So what do? We first have to reverse it. So this is in the front, this is second, this is third, this is fourth. So we just reverse the list, and then every element in this last element or last list, we just append it to our output list. And then when we are finished iterating through all of the elements, we just remove the last element of input data. So we just remove this whole part of block of code. As you understand it, first we take this, we reverse it, then each element we append to our output, and then we delete it. It looks like this: 8, 1, 9, 9, and 7. And then we delete this list altogether, and we are through the third part of our code. Yay. Now the last and the fourth part of our code, which is like this. It says append the first values of list that remain, but reverse the list first. Because if we wouldn't reverse the lists, what would happen? This is an array that is left, and this is a list. Both are lists. This is list and this is list that we are left with. And if we would just append to our output the first variables, we would get like this. This is 4 if you don't see. We would get 5 and we will get 4. But this is again not in alignment with what we want to achieve. We want to travel in this direction, so we must first select 4 and then 5. So firstly, we just reverse this whole array. So this is the first element now, and this is the last element now. And we take the first element from these two elements. So first we have 4, and then we have 5, and both we remove. I will just cancel these circles. We get 4, and we remove the 4, and then we get 5, and then we remove the 5, and that's the end of it. And then we reverse this back again. So again, this is the first one, and this is the second one array. And then we just do that all again. And we are doing that until there is no more elements in the list, and then we just output the data. So now if the code would run, we would just first get 1, then 2, then 3, then 5. That's what it looks like. Now, with your new knowledge of this code, with your new knowledge of this problem, you might be asking yourself, so why is everything not working? Everything seems clear and everything seems right. What's wrong? Now that is the question that I was also asking myself. So I first asked myself, wow, maybe the Python runner in this website is not correct. So I took all of this code and put it in my here and made a test with myself, but that didn't work. I mean, that worked, but it still gave me the red attempt of the test with a long input. And that is another thing that we can see, because every test that doesn't pass includes a long input. Now, that may tell us that our code only fails with long inputs, with that much data that we can hardly visualize. Like this. I don't even know how many elements are here. So, the first thing is that I tried to do was that I tried to look at this code the other way. So I got into my terminal in my own computer, and I created a simple empty folder called app.python, py. And this is the app.py is the sample, is the like default name for Python files. And I went into my local code editor called VS Code. I took this code out, copied it, and pasted it. As you can see, this code editor has little more friendly colors. Now, first, we see that all the lists are green. Why is that? That is because in Python language, a list is also like not only a variable name, but also an object name, object of a list. But that is more advanced stuff. Actually, right here, everything is a little bit more advanced stuff, but not too much. Now, the thing that I did was right in this second part of code. Remember what this second part of code does? Oh, it is the part of code that removes this part and this part. Now, first we take first we take the last element of each list and append it to our output list, and then we remove the set element from the input data, like so it doesn't and then we remove it. It's self-explanatory. We don't want it there. Now, the thing is that I first realized is that these two lines of code are too much, because these both things I could just write in one line. And that just boils down to knowing of the language. Because when you're programming, is like when you're speaking a language. And the more words that you know, the better you can program. So, one piece of this knowledge is that whenever you use a pop function, the pop function removes the element from the list with this index, with this element from this list, but it also returns a current value. So pop is the same like remove, but remove function doesn't retrieve the item that we have removed. Let me demonstrate. Let's enter the Python code again, and we say, let's enlarge that a bit. We say sample list equals 1, 2, 3, and we print the sample list is 1, 2, 3. Now, if we say popped item is sample list dot pop, and we take, for example, the last item, what has happened now? According to my explanation, in sample list there shouldn't be the last item. So let's print out the sample list. There isn't. I was correct. There's only 1 and 2. But what is the popped item? It's 3. So I have done the same as if I would do here. That first I would take value from the list, and then I remove the value from the list, and I can do that in a one line. So I can out comment this so that I still see what I have written, and I just do this output list dot dot append. I want to append it the last item of a list, and I do that with the pop function. And the good thing about the pop function is that here, if you don't add in a parameter to this function, it automatically removes the last item of our list. That is also some knowledge that I got from knowing Python language. So if we just for readability reasons remove this part of code and take all this code, copy it and paste it inside our Code Wars website's code editor, like this, paste, and if we test it, the results are green of the sample tests. If we make a whole attempt, every suite is green. We can successfully submit our kata. We have been successful. Now, you might ask yourself, hey, Rok, didn't you just do in you As far as I can see, you just written one line what happened to be before in two lines, and now your code magically works. And I say, yes, your observation is correct. And that shouldn't be a reason in programming, that just because your code is shorter that it works better. It's just that I stumbled upon this solution on accident. I didn't know that this was gonna solve my problem. But as it is evident from this example, we can sometimes make debug our code just by making it more verbose. Now, if you stick around in the next video, I will analyze what this what this what did I achieve by changing this part of code, and how um, did it work behind the scenes that the algorithm, because of this change, worked correctly. So, thanks for watching and goodbye.